All right, guys. Good morning. Welcome. Hopefully you're all in the right place. We're gonna have 90-minute painful conversation on SD WAN. No, I'm joking. Hopefully it'll be okay. How many of you are using some kind of Cisco SD WAN solution today? All right, keep the hands up. How many of those are Catalyst? So it's almost everybody using Catalyst. Okay. So what we're going to do today is we're going to give a really brief overview on what we mean by SD WAN, the capabilities, and then kind of compare and contrast the capabilities, the SD WAN capabilities between Catalyst, which is our flagship SD WAN platform, of course, what we can do in the Meraki MX platforms, which is also something we consider an SD WAN platform, and talk about the SD WAN capabilities in our firewall. And before you're like, oh, Cisco's got 3 SD WAN platforms. We don't position the firewall as an SD WAN platform per se, but we did feel it was very important to have an SD WAN feature set in there because we're competing against the other big firewall vendors, and they all have pretty capable SD WAN capabilities. So we'll wanted to compare and contrast, and then at the end we'll talk about how they all integrate with our security service edge, known as Secure Access. And I think a few of you were in the Techtorial on Monday. So this won't be a super big deep dive on Secure Access, but more focusing on the integrations. So in order to do this, what I came up with is kind of a way to talk through like an ideal use case for each platform. It's always tricky with this kind of thing because you don't want to like disparage one plat, like, oh, well, this one's good at this, but it sucks at this other thing. Like that's not what today's about. We really want to talk about the capabilities and how customers can be best informed to make the best design decision based upon your use case. So this will be the agenda we'll go through. So a little bit about me. I think it's my 45th Cisco Live. So thanks for that. Coldest one in Melbourne, as it was discussed with the guys up front here. I got a daughter who works for Cisco. That's her there. She's one of the products we'll mention today, Security Cloud Control. She's in the marketing team for that product. And yeah, there was all my badges. I got them in a big box at home. So, all right. So let's get into the basics. By the way I've structured this, we should have time for questions in line. So if I see a hand go up or anybody look mildly interested in what I'm saying and raise an eyebrow, I'll encourage you to ask a question and I'll try to repeat it back so everybody can hear it. And if I don't do that, hold me accountable and we'll make sure, because I always hate when people ask questions. I don't hear the question and then I get some crazy answer. I only hear one side of. So SD WAN basics. So when I started in this business, I'm 53. So my first job out of college, our corporate environment looked something like this. We had 2 branch offices. One was in Lansing, Michigan, and one was in LA, and the headquarters was in Boston. And we had 56 kilobit lines to that, if anybody remembers those. And then we had a firewall, checkpoint firewall at the time, connected to the internet. And this kind of general architecture went on for quite a while, right? And obviously as internet bandwidth increased and the ability for customers to put in capable internet access at all of their sites, this old architecture, nobody deploys this anymore unless they have it kind of left over. So we introduced this concept of direct internet access, which just means, okay, yeah, I probably need connectivity from my branch to my headquarters, but if traffic's going to the internet, just let it go direct out to the internet. And this basic capability worked pretty well, but a lot of the applications we access, SaaS apps and so on, becomes tricky kind of describing with IP address rules what the routing policy should be. And that got us to this concept of software-defined routing and software-defined wide area network. And all software-defined WAN or SD WAN means is I can have some kind of intelligent rules that make decisions on how to route traffic based upon some sophisticated stuff that's more than just an IP address, right? If all you're doing is making routing by a routing protocol, I don't really call that SD WAN because it's just, you got routing rules and saying where the traffic's going. So we can do stuff based upon applications, maybe application performance, jitter and packet loss and all that stuff. And when we get into software-defined internet, it's basically the same thing, right? And even if you don't have connectivity between branches, if you only have one location and you have a couple of internet links at that location, you can have software-defined internet because you want to make the best use of a couple different links. So these are kind of super basic capabilities here that we've built solutions around. Now, why secure SD-WAN? Because this session's about, we want to have a secure SD-WAN platform, aka firewall and those types of capabilities in there. We want to be able to enforce policies as close to the users as possible. And this was always a reason why we backhauled everything to the headquarters before, right? Because you had your security stack at your headquarters where you did all your inspection and rules and stuff like that. Well, if I'm going to have direct internet access, I got to do all that security stuff right in the branch. So secure SD-WAN, now I can do things like URL filtering, DNS inspection, maybe intrusion prevention, maybe decryption, all right in that branch platform. So when we say secure SD-WAN, this is all we're talking about, right? We don't just want routing, we want firewall capabilities in that platform as well. Is that good enough overview? Because that's all you're getting on the overview. So I think everybody's pretty comfortable on SD-WAN there. So if you got to give a 3-slide, what the heck is SD-WAN to somebody, you can use that one. All right. So now we're going to get into the use cases, and we're going to start with Catalyst. So the way I like to talk through this is these kind of steps, and no matter what kind of platform you're going to go on, you're going to have all these considerations, right? So we're going to go through a brief architectural overview of Catalyst. How the provisioning works, and this is always important, especially if you got hundreds of sites. You don't want to drive all the way across Australia to deliver routers and firewalls and stuff. What the WAN fabric looks like, how routing works, the analytics, and then lastly, the security capabilities of each platform. So we'll start with the architectural overview in Catalyst. And the Catalyst platform is unique among the offerings in that it has a dedicated controller and it has a separate dedicated control plane that is completely separate from the data plane where your end user packets are. Meraki's can be a little similar to this, but we'll get to that. So in this case, we have Catalyst SD-WAN Manager, formerly known as vManage for the folks that were using the Viptela naming convention in the past. And then you had some orchestration things. We won't get into vBond and vSmart and all that here, but the platforms that basically constructed the data plane. And then for I think I got a laser here. Yeah, there it is. For your actual sites at the bottom, these sites have an out-of-band control plane up to vManage, and then they build the VPN tunnels, the software-defined WAN between all the sites. And all of the orchestration and automation happens up in this orchestration plane. By the way, this is can either be a SaaS offering, a Catalyst SD-WAN Manager SaaS, where Cisco hosts it. I recommend that because then we keep it up to date and there's less care and feeding. Or you can host this yourself, either on-prem or in AWS or some such thing if you prefer. Now, that out-of-band protocol we call OMP, Overlay Management Protocol. And I promise I won't kill you with too much detail here, but suffice to say the Overlay Management Protocol runs between all the routers and those SD-WAN controllers. And the job of this protocol is to let every branch know about every other branch and what networks are behind it. And what that allows Catalyst SD-WAN architecture to do is to build, if and when needed, even branch-to-branch tunnels directly between two branches, which this is the only platform we have that does this out of the box. Now, why would you want to build direct VPN connectivity between branches? Think if you got 1,000 branches. Because the problem with this, if you just wanted connectivity between all of your branches directly all the time, well, let's scale it down. Let's pretend you had 3 locations only. Well, if you had 3 locations only, each of the 3 locations would have 2 tunnels, right? So it's n to the m-1. 3 locations, not so bad. Now imagine you got 1,000. Now it's 1,000 n to the n-1. You have thousands of tunnels, right? So what OMP allows us to do is only dynamically build up a tunnel between spoke to spoke if there's ever a call for traffic between those two. When would that happen? Phone call, literally. So now, you're probably not going to see many hands go up. How many of you are running an IP call center on your network? Cisco call center or VIA or something? Not a single hand in the room. One guy, okay. You were stretching, so one guy. So, if you have a call center and you're running on-prem voice, it's pretty common. I call you office to office. We don't want that traffic to ping pong to the hub. The connectivity directly between offices can automatically and instantly be brought up when we make the phone call. OMP allows this to happen. With the Catalyst, we also have something, and I won't go into more detail because it gets crazy here, called multi-region fabric. So we can support literally tens of thousands of branch locations with Catalyst using this multi-region fabric design. And this would be think of a customer who has thousands of or hundreds of locations and in dozens or hundreds of countries. They're going to want this design. Is there a question in the back there? You read somewhere that this model is being discontinued? Not yet. As we scale up here, the number of customers that need to implement this design is pretty small. So I got it in here for reference, just to show the capability for scale here. But
I wanted to implement it, and then I was told by Cisco advanced services not to deploy because it's going to be
let's talk after, and we'll get together on that. All right, so let's now talk through the security capabilities of the Catalyst platform. And I broke this into a few different areas here. Now, first in the upper left here, we'll talk about fabric security. So the actual security of the VPN tunnels, of the WAN tunnels themselves, and of remember, all of the routers have that out-of-band connection where they get their configuration. We need to secure all that. What if I steal a router from a shop or a remote location with nobody, and I bring it to my house and try to get it back online, right? Or what if I get a copy of the configuration of one of those branches, and now I want to try to insert my own branch into your SD WAN fabric? Would that work? And the answer is no, it wouldn't, because we do a hardware-based device authentication. So all of our routers and firewalls and switches and everything at Cisco has a trusted compute module, a TPM chip on the motherboard. And that TPM chip is used to store certificates and unique information from the router that can be validated when it connects into your control plane. And that allows us to not only encrypt the control plane, but to provide protection against somebody trying to switch out a device or move a device, that kind of thing. Now, more on in the middle here, more on the protecting your user traffic, the data plane security. The Catalyst platform is effectively a full-fledged next-gen firewall platform. It has all of the capabilities that you would expect in a next-gen firewall platform, a stateful firewall that's application-based. We have intrusion protection, URL filtering, a malware protection, what we used to call AMP, Advanced Malware Protection. This came from the SourceFire technology. So all of the capabilities you'd expect from a next-gen firewall platform can be configured on the Catalyst routing platforms. And as we'll see, you can now manage these in the cloud and security cloud control or directly in your Catalyst SD-WAN manager, aka vManage, as you like. Now we have the ability here on the right for cloud security integrations as well. So this is things like integrating DNS security with Cisco Umbrella, the formerly known as OpenDNS, right? So that Umbrella DNS security with a simple policy, we can connect Umbrella DNS into the routers and enforce that. We also have a full integration with our Cisco Security Service Edge, known as Secure Access, that we can connect in, and we'll talk about that a little bit more here as well. So a lot of security on the data plane side, on the fabric side, and then of course there's monitoring that we'll talk about here and analytics that we perform inside of the UI as well. Here's what that UI looks like. On the Catalyst platforms, you'll find something was most of the folks running it here in the room. It's very template focused. The configuration is meant to be normalized across all your platforms. Now that doesn't necessarily mean like one template for all 100 sites, but probably like if you have 10 sites that all have the same model of router, and all 10 of those sites have 2 internet connections, you're probably going to want the same configuration on all 10 of those sites. You'd have a site template that has the routing template, the firewall template, and so on attached to it, and that template configured for all 10 sites. This makes scaling up Catalyst SD-WAN deployments very, very easy, because if you build your templates for 10 sites and you add 1,000 more, it is almost no additional work. Now, the corollary is also true. If you only have 10 sites, you had to do the same work as configuring 1,000, so to speak, and that you have to configure these templates and so on. So this is why this platform is quite popular with managed security service providers, MSSPs, is because they can very easily have a known good configuration and template it across a large number of sites. And the workflows and the troubleshooting and the monitoring inside of SD-WAN Manager are excellent. As is the zero-touch provisioning. So the zero-touch provisioning on Catalyst was meant to allow the customer from the ordering process to implementation be zero-touch. So when you order a Catalyst platform, on the order you can say, you give it the smart account and so on, and that device can be drop shipped right to a remote location and connect the red wire to port 1 and the blue wire to port 2, that kind of thing. That device will boot up, will phone home across the internet to Cisco's plug-and-play server, authenticate itself with a certificate on its TPM chip. The plug-and-play server will know, this is Acme Corp router. It will connect it into that Catalyst SD-WAN Manager. You get the idea, and that site will come up 100% on its own. So this platform, it's a similar experience to Meraki, as we'll see here, but this platform is really optimized for that zero-touch experience. Now, on the application experience side, talk through some things that we uniquely do on Catalyst. Okay. And they're all around data and application optimization. It's a little bit of a build here. So the first one is TCP optimization. So depending upon the links and the amount of loss that the customer has, et cetera, we monitor congestion across the links. We automatically manage things like TCP window size and all of these kind of nerd knobs that you can adjust at the IP level layer that you don't have to because the platform looks after it. We also perform something called forward error correction, which I remember when I first learned about this a long time ago. It sounds like nonsense. Like, how do you correct an error in advance? Well, what we do with, what we do with forward error correction is, and this requires the site has 2 links, so 2 internet links or an MPLS and an internet, whatever. We'll actually send packets out both links. And we send packets out both links because if you have a little bit of packet loss on each link, when those packets arrive on the other side, the receiving router can kind of put them together, and you can sustain the errors, thus forward error correction. And only the Catalyst platform does this. We also have, the top's just management. We also have compression built in. So if you guys remember the old Cisco WAS appliances, those were compression. It basically did LZW compression of the links at the data layer, and we'd sell you these expensive appliances, and they had hard drives in them and stuff to make better use of your WAN links. We just built that into the Catalyst. So LZW compression, along with TCP optimization and the forward error correction in this platform, makes it the #1 platform, not just from Cisco, but from any vendor for traffic resiliency, especially when you have kind of lossy connections, maybe high latency, high packet loss, that kind of thing, which you can often have in remote locations. So another thing that we do is we have a service insertion capability, and this allows us to have what we call application-aware routing. So you can classify traffic, yes, by applications, and that means layer 7 applications. We also allow you to classify traffic by security group tags, those ICE TrustSec security group tags, and you can configure policies for traffic of various classes and applications, and that policy can not only say I want this traffic to go out this link versus that link, but you can perform and have different inspection or different decorators, if you will, applied to the traffic based upon that. And we can get pretty sophisticated here, and again, easy to configure, especially when you have multiple paths here. So in this example, this site has an internet connection, it's got an MPLS connection, and a 4G LTE wireless connection. And these are usually expensive, and you're paying by the packet or paying by the kilobyte across those cellular connections sometimes. So it's generally desirable to, hey, I'll only send traffic across this expensive link if I really need to. If the other two are down, or it's a really important traffic and the other two are having lossy connections. So we can very easily do things like, hey, if multiple paths meet the SLA, hash the traffic, meaning send it across both paths, and then I get more bandwidth. That's cool. Or you can say, well, if path 1, which is internet, is preferred and it meets the SLA, just send it across path 1. You can do that too. And then you can have preferences and fall down to MPLS and fall back to the cellular, for example, with that. So you have very sophisticated ability to create routing policies and preference and priority of the links based upon the application. And you could do all this on a per app basis. You can get pretty crazy here. Like generally I group things together, like, okay, this is critical traffic, this is collaboration traffic, maybe everything else. So I might have 3 policies, right? Because if somebody's watching YouTube, I really don't want that going over the LTE link. But if it's my point of sale system, yeah, like that's got to work, right? So you're going to be pretty selective there. We also, on the Catalyst platform, and it's the only one that offers this, we support what's called per tunnel QoS with shaping. And this is pretty sophisticated because remember, a given edge could have hundreds of tunnels. Now, generally, it would only have tunnels to the hub locations, but as we talked about with the dynamic ability to bring up tunnels, you have this notion of wanting to optimize the traffic inside each WAN tunnel, and we can do that. And this is especially helpful if the tunnels are connecting to different locations that have different bandwidth, and we can shape for that. And then we also have the ability to do shaping inside the tunnel on what we call a per VPN basis. Now, this was a confusing term for me when I learned it, so I'm going to go slow here. So the pre-VIPTELA, the term VPN just meant virtual private network, and if you had a connection between 2 sites that was encrypted over the internet, we called that a VPN, right? In the Catalyst SD WAN parlance, the term VPN is used to reference a virtual fabric across that SD WAN. Now, why would you want to do that? Well, if you're just one company and one org and you have a SD WAN fabric, you're probably not going to use this concept of a VPN across your fabric. You're just sharing everything together. Please. Yes, I know.
So are you going to cover DVTI tunneling?
I will. So the question is, am I going to cover DVTI? I'm going to cover it when we get to firewall, but not here. So thank you. So with this VPN, the cool thing, and this is a unique capability of the platform, I have many customers who think a good example is like a municipality. So a municipality might have a wide area network of all of their locations across the big city, but they want the police department and the library to have their traffic not commingle across the link. the Department of Natural Resources and the fire department and so on. So with the Catalyst platform, you can actually have a virtual fabrics across your SD-WAN so that you can logically keep traffic separate. Also helpful for mergers and acquisitions and a whole bunch of other examples. I'd be curious to hear yours later. So if you have a scenario where you need this type of virtual fabrics across your WAN, the Catalyst platform is great for this, and we can actually do that per VPN QoS. Now, I mentioned the forward error correction. I'll kind of leave this here a little bit for reference, how you get the idea. We'll send the packets across 2 tunnels. Each lost a packet. Then the receiving end puts it all together, and everybody's happy. So this I always recommend keep turned on. And the number one example of where this is super helpful, again, is where you have a unified communications deployment in a customer environment. Now, I would say 90% of what Cisco sells today, and our competitors as well, with regards to unified communication, is all cloud calling, right? So if any of you are a WebEx cloud customer, if you're a WebEx customer, you're a cloud customer, when you pick up the phone and make a phone call, that call goes up to the cloud and then back down to whoever you're calling, even if it's the gal next to you, right? So in a cloud calling environment, this doesn't really help so much, but where you have call center deployments and you have on-prem unified call manager, or even with a competitor via something like that, and now you're making calls can be phone to phone. The Catalyst platform is ideal for this, and it is a very, very well integrated solution to optimize that experience. So let's talk a little bit about the monitoring. So as we mentioned, we have both an underlay and an overlay. The underlay is just the internet or an MPLS link. But then we build those tunnels, those VPN tunnels, and that would be the overlay, right? So we need to monitor both. So inside of the Catalyst SD-WAN Manager, we have a whole bunch of very detailed reports that monitor applications and trends and aggregate data across interfaces and sites and so on. We also have extensive troubleshooting capabilities where we can visualize flows across different sites and so on. And again, this is the number one platform for this, like especially for a large environment when you're trying to troubleshoot potentially quality problems of an application or something like that. We have very sophisticated monitoring here, and then we'll also do something called predictive path recommendations. This one's pretty slick. We patented this. This will even take into account, like we see, hey, every day around noon, these traffic patterns change, and we see a link get saturated at the same time every day. People are on lunch, maybe they're all watching Netflix or something, right? So the proactive path recommendations might automatically, make some forwarding changes based upon, these reoccurring traffic patterns is just one example. We can also optimize SaaS traffic using this, and we have a AI ops function in Catalyst SD-WAN Manager that looks after this as well, and we'll make these recommendations. So pretty slick. Now, on the segmentation side, I mentioned earlier that these platforms support TrustSec. And then I also mentioned that VPN thing, right, where you can do this kind of segmentation of my traffic. So this is a little visual representation of that here. So we can do, we're going to start with the macro segmentation here in the top. And this would be hey, I want the police department traffic separate from the fire department. And I can have, those packets not commingled across the link, across that fabric. But even inside of the different VPNs, I have contextual policies I can apply based upon the Cisco TrustSec tags. And the way these TrustSec tags work is pretty simple. Usually, Cisco ICE would be the thing that would assign these. We can assign these tags. Now, you'd name them, but for the slide here, I just got some colored numbers here, 10, 20, 30. So depending upon the user role, I can say, okay, Dana there's an employee on a managed laptop. She's going to get tag 10. Jeannie's in finance, tag 20. This is an IoT device, a printer. It's going to get tag 30. Maybe all my IoT devices get tag 30. When those packets flow across the network, not only can I have different routing policies for them if I want, I can have different security policies for them if I want, and I can prevent maybe the guest tag from talking to an IoT device tag. My guest shouldn't be able to print. My guest shouldn't be able to talk to an employee either, probably, right? So you can have pretty fine-grained policies for there. And we use these tags quite a bit in campus segmentation, in many environments, healthcare and so on, and you can use them across the SD-WAN fabric now as well. So that segmentation using these coarse and fine-grained, of course, this is in combination. You can also just create your regular firewall rules based upon IP addresses and apps and so on. But this coarse and fine-grained segmentation on tags can be quite helpful and quite powerful. For all of the next-gen firewall capabilities we have in here, we have full reporting inside of Catalyst SD-WAN Manager, and I'll demo in a little bit. We also now have an integration we just went live with last week, believe it or not, between Catalyst and what we call Security Cloud Control. Talk a little bit more about that later. Punchline there is Security Cloud Control is our SaaS offering where you manage all your Cisco security products. We plug in now Catalyst SD-WAN Manager in there as well. We also this past year completely overhauled the firewall rule table. What we found was most of our Catalyst SD-WAN customers did not configure the firewall rules or didn't make very sophisticated firewall rules. And I'll ask the gentleman in front, did you think it's easy to create firewall rules on the Catalyst? Yeah, so what I heard was no. So it wasn't. So I helped redesign this. So we completely overhauled this firewall rule table, the look and feel, and just made it much easier to use. And we referenced it after our Cisco firewall UX, so it looks and behaves pretty similar. And as you can see, you can include things like TrustSec tags and applications and Entra ID or Active Directory groups, that kind of thing, layer 7 firewall rules. So by the way, this is in that August release. It's pretty new. You're probably not running it yet. Most folks are always 6 months behind on the releases here. So that's new, and we also have the ability here, to skip ahead, we also have the ability here to send all of the firewall logging back to Security Cloud Control. So before this release, you could only look at your firewall logs on the router in Catalyst SD-WAN Manager. Well, your SecOps team is probably not logging into Catalyst SD-WAN Manager. They probably got a SIM, or if they're using Cisco Firewall or a competitor, PAN or Fortinet or somebody, they're logging into that console, and that made them probably never look at the logs of their routers, or even not want to configure firewall policies on those platforms. With that same release, we will integrate all of the firewall logs. So we take the firewall logs, the syslog, and the IPFix NetFlow from the Catalyst platforms, and we forward it through the cloud over to Security Cloud Control. And in Security Cloud Control, this is what I'm showing here, we have a unified single event viewer, which will show you all the firewall logs for ASA, FTD, and now Catalyst SD-WAN platforms. Meraki coming, by the way. So we wanted to provide a unified place for all the log viewing. Of course, you can send it all to Splunk too, as we've seen. So, yeah, it's a question?
Around the firewall rules, can they be templated?
Can the firewall rules be templated? Absolutely. And in fact, you must template them. Now, to create firewall rules, you create a firewall rule template. You can choose to assign that template to only one router if you want, but you've made a template no matter what. And this is what I was kind of poking at earlier. The templates are great because they allow you to very easily configure many devices the same way. The downside is you must always create templates. There's no concept of, I'm just going to go in and directly edit the firewall policy of this router. You're editing the firewall policy of the template attached to that router. And if you've attached that template to other routers, you're modifying those as well, which is usually what you want. But you gotta kind of get into this mindset, right? So that's what I was referring to here. So Security Cloud Control, this is our SaaS portal. And Security Cloud Control, by the way, it's not something you buy. If you own any Cisco security product, which now includes a Catalyst SD-WAN router, you get a Security Cloud Control login. And when you log into Security Cloud Control, assuming you're a Catalyst SD-WAN customer, you can go through a little guided workflow and connect your Catalyst SD-WAN manager over to Security Cloud Control. And optionally, if you want, you can have those logs go to Security Cloud Control. Just a second. We do charge for the logging, by the way, because the logging's eating up storage, but just the ability to manage the firewall policies, we don't charge for. What was the question?
You answered it.
That was the question. Okay, I thought it might be. So in Security Cloud Control, we do charge for logging. We have I think it's 90, 180, or 1 year of data retention per platform. The 90 days is, I think, what most customers go with. So, all right, so that was the Catalyst SD-WAN walkthrough. And as I promised here, the idea was to kind of give a use case story around where this platform can be optimal. I mean, it's obvious you could use the Catalyst SD-WAN platform in literally any scenario. Where you have, the strong desire to have some micro segmentation even across the WAN, where you have a collaboration on-prem collab deployment, many other use cases here. And this is why this platform is the default recommendation from Cisco when a customer says, I need an SD-WAN solution. Now, any Cisco SE that immediately gives the recommendation without asking questions of customers, not doing their job, right? It's like, okay, well, what are your use cases? How many sites do you have? Tell me about the sites. Do most of them have multiple internet links, and on and on and on, and you can give a better recommendation. And obviously, many times that recommendation is like, hey, I think the Meraki MX platform would be great for you. Or, hey, we got PAN firewalls at all our sites now, and that's our SD-WAN platform. We've built complex security policies around them, and our SecOps team manages those policies. Catalyst might not be ideal for that kind of customer, and when we get to firewall, we'll talk through that example. All right. So I'm going to go to part 2 here and talk a little bit about Meraki. Now, Meraki, like Catalyst, is really good at many things. The philosophy behind Meraki and the design, and we go through this whenever we add new features to Meraki, where Catalyst allows and almost encourages and sometimes requires the configuration of very granular settings and controls around every feature. In the Meraki platform, we go out of our way to make the best recommendation or decisions as default possible. And if we believe 90% of customers will want the default choice, we don't even put a knob there anymore, because we want the platform to be known for ease of use, ease of deployment, and very reliable, not easy to shoot yourself in the foot kind of outcomes, right? And this is the basic design philosophy around Meraki to make it easy. And from the SD-WAN platform capability, seeing most of the same terms we talked about here. There's a couple we don't have. Remember that forward error correction and the compression, some of those things, like most customers don't need that. Meraki doesn't have it, that's why, right? We also did some cool things here. So Meraki MXs now, I saw some hands earlier. Assuming you're running I think it's 17 something or other, we can deploy a ThousandEyes agent right in the router. And if you're a ThousandEyes customer, now all of your Meraki sites have a ThousandEyes agent built in, and you can run tests, and it's a super slick and easy way to do advanced, sophisticated network monitoring without the customer having to spin up a VM or a Raspberry Pi or God knows what they want to run the little the ThousandEyes container on. We built right in here. We also have very capable third-party IPsec support now. We didn't used to in the Meraki. Now it's quite advanced. IKV2 IPsec. We support BGP routing across it, et cetera. And then you know, the cloud connectivity, the Meraki platforms require cloud management, no surprise. And here's how that works, right? So when that device first connects in, gets an IP address, and it immediately builds a management tunnel up to the Meraki cloud. It's a TLS tunnel. The serial number, which again is stored in TPM chip, is used to register itself to the Meraki cloud, which then knows what tenant you're in. And you effectively can't buy a Meraki MX without giving us your org. So when you then go into the Meraki dashboard and you put in that claim number, it's on the box that the firewall came in, that immediately attaches it to your tenant, and you can have a configuration ready to go, and it's a really, really nice, easy experience. In fact, you remember I gave the example earlier, like, yeah, the red wire in port 1 and the blue wire in port 2, even if the person's colorblind, they plug the cord in wrong, as long as one of the ports is connected to the internet, the box will figure it out and phone home, and it'll tell you to move the cord. But it's really good at, you know, the helping the early in career engineer get the thing online. So for the fabric connectivity, we have something patented here too. This is really nice. It's called Auto VPN, and this just works out of the box. So this will contrast this when we get to firewall, because firewall allows you have all kinds of sophisticated options for how you want your VPNs to work. With the Meraki, it's real easy. You start plugging in these MXs, and you just say auto. And all you had to do was like say, well, this is my headquarters, so that's a hub. And it'll just automatically deploy all the VPN connections from all the branches to the hub, or hubs if you have more than one hub. And it'll also figure out, hey, this branch has 2 internet links. I'm going to build tunnels out both links, and it just works. You don't tell it to. You don't have to, you know, kind of fuss with it. So this is again that Meraki philosophy of make an educated guess on what the customer wants as an outcome, and just do it. And don't allow for so many choices that the customer feels overwhelmed on, boy, do I need to fine tune this thing, and so on. We do a pretty good job, not perfect. Sometimes it's frustrating. It's like, how come I can't fiddle this? And you know, sometimes we go in and we add a little more settings here. But the Auto VPN out of the box with Meraki is, to me, it's the gold standard. It is really, really easy to get going. Now we do have sophisticated tunnel monitoring. If any of you are running Meraki, you probably see this. We now also support, as I mentioned, BGP over IPsec, which is pretty slick. This is one of those examples. Like, we were doing BGP across Auto VPN 10 years ago in the Meraki. We didn't show it to the customer because we didn't want our customer to have to be a CCIE routing nerd to get the VPN working. Well, we got a lot of CCIE routing nerds that buy Meraki now, and they want to have special routing configurations on the WAN. Here you go, right? So you know, that is there, and you know, for those advanced deployments now that need it. A little bit on the tunnel monitoring here. This we enhanced this pretty dramatically in 19. So this is basically we always did this in Auto VPN, but the problem was if you were manually creating IPsec tunnels, VPN tunnels from Meraki to something, usually a non-Meraki destination, you could not have 2 tunnels with the same kind of routing configuration on them both. The Meraki dashboard would scream at you and say, you can't do this, you already got that network on this other tunnel. And you're like, yeah, but I want a backup tunnel. Too bad, right? So now we do support that fully with the Meraki, and this is particularly helpful if you're connecting the MX to a security service edge, something like Cisco Secure Access, or even a competitor, you know, Zscaler or something like that. So if you have the Meraki MXs and you want to connect them to Cisco's or anybody else's security service edge, that tunnel redundancy is you know, generally perceived as pretty critical. We have excellent reporting in here, and this is something that we improved over the years. There's a dedicated VPN peer-to-peer log here, and the tunnel status accurate it just kind of implies it wasn't accurate before. It wasn't. It didn't update very often. Now when you go into this page, it does active polling to show you, like, because if you've got 500 sites and 2 of them don't have a tunnel up, you don't want to find out when the help desk ticket comes in and somebody's screaming, right? So this will do really nice reporting here. For those WAN links, we also do active probing, and the probing is used for the QoS type stuff and to failover links and what have you. Once again, like on the other platforms, you configure this. On Meraki, we just set it up for you, and like it just works. So you don't have to fuss. Like we document how the probing works here, and you can't change these intervals because we found that that's what it works for most people's environments, just the way it is. We also then, from those probing, this is how we make decisions on link failover. And you can customize the link behavior. So if you have a Meraki MX with like 2 internet links, you can tell it, well, here's the bandwidth of my links. This one's got 1 gig down and 100 meg up and so on. And it'll automatically then optimize traffic across those 2 links. And you can make some overrides if you want. And we do this with some buckets that I'll show you in a second. So you can do things like, hey, I want my, that YouTube type traffic to go out to maybe the cheap internet link, and these kind of business SaaS applications, I want to go out the higher quality link, things of that nature, just like before, and showing that here. So we call those performance classes. You can say preferred uplink, failover if, poor performance. The performance class is VPN, like really, really simple. You don't have to be a CCA routing nerd to configure the application QoS in Meraki. It's all human language readable terms to create these behaviors. So I really do recommend this platform quite often, especially in the friendly way we say it is a lean IT, which is a nice way of saying two guys and gals and a cat or something managing a large environment. This is going to be very, very easy to manage at scale. Again, you can customize these classes as well if you need to. All right, so we also have the ability to do application-based routing as well. And a few years ago now, we implemented NBAR, which is the application routing detection engine that initially came from Catalyst, is built into the Meraki now. And that allows us, again, we do this by kind of category, and I'm showing here like web file sharing, and I want my web file sharing to use a certain link, et cetera. And you can create your own as well. And this dependency, or this use, I should say, of MBAR also gives us a capability for this software-defined application visibility and control. And the reason why Cisco invented this SD AVC, and we patented this, and all of our Catalyst platforms use this, Meraki uses this, and we're building this into some of our security solutions as well. This allows us to have what we call first packet detection of an application. Why does this matter? Well, if I have 2 internet links, and let's say I create a rule that says I want Office 365 traffic to use link 2. Well, when the first packet comes out, there's a TCP 3-way handshake, and then a TLS client and server hello, and then you start sending Office 365 data. By the time that happens, you're 25 packets into the flow. And now we detect, this is Office 365, it's supposed to go on the other link. We just start sending out the other link. What do you think happens? The connection resets, the user gets a crappy delay, and it's not nice. It works, and this is how all of our competitors do this type of application routing. With SDAVC, we use signature mapping so we can detect, and our track record is pretty good, 90% of all applications we can detect on the first packet, and then we can match your routing rule on the first packet so you don't get this crappy reset experience that our competitors see. Meraki MX uses this, the Catalyst uses this. FTD, when we get to, uses a different method, but that achieves the same goal here, by the way. We also have ThousandEyes built in. How many of you use ThousandEyes? Cool, so about a quarter of the room. And for the uninitiated, ThousandEyes, obviously a network monitoring solution. It's very powerful, but it is a little bit of a labor of love. You go in and you have to learn how things work, create these tests. It gives you really, really cool reports and so on. When we wanted to integrate Meraki, we wanted to make it easier. So we kind of automatically configure tests, and we suck in some of the, this is an example of a path visualization from the ThousandEyes dashboard, and we show it right inside of the Meraki dashboard. So in this example here, like anybody can figure out red's not good, right? So if I'm measuring across this path, where that link's red, probably got some internet router or something that's dropping flows. So the end-to-end visibility here, and like I said, all Meraki MXs now, you can turn up the ThousandEyes agent built in. Now in the firewall capabilities here, we have pretty robust set of capabilities across the board as well. You know, the one I would caution on, the platform does technically perform TLS decryption. This is meant for selective decrypt, where I have a particular rule or application that I want to decrypt. This platform, frankly, not ideal if like you want to decrypt all your traffic going through your internet link. Not with the MX. It's not, the hardware's not scaled for it, and the behavior of doing that in a way to make exceptions and so on isn't great. You know, that said, all the firewall capabilities very powerful. We have IPS and AMP and so on. It uses Snort engine under the hood. And in the Meraki, we have a security dashboard that kind of rolls up everything. And there's a tight integration here with Cisco XDR as well with the Meraki MX platforms that, again, is very, very easy to manage. We also support the ability to enforce security policies based upon those TrustSec tags. Now, we don't do the segmentation across the WAN that I was describing with Catalyst, but we can use TrustSec SGTs and do that enforcement not only in the MX, I can enforce them on the Meraki switches and wireless as well, which is pretty slick. So Meraki took that security group tag information and basically simplified the policy so that it could be enforced everywhere. So pretty nice implementation. And again, to speak to how easy it is to turn things on, this is how you turn on advanced malware protection. You just take the drop down from disabled to enabled, done. So, you know, in the other platforms, you're creating, you know, which applications and clients do I want to support and so on. This is really simple, and you can whitelist. Likewise, for what we now call secure, the secure malware analytics, formerly known as ThreatGrid. This is our cloud sandboxing technology. So if the Meraki MX inspects a file for malware and it comes back with an unknown signature, because the advanced malware protection basically does a hash of the file. It phones home to the AMP cloud, and the AMP cloud comes back and says, I know that file hash, it's bad. Or I know that file hash, it's good, it's a Microsoft update. It could come back and say, I've never seen that file hash before. The Meraki MX will upload the file to ThreatGrid, now known as Secure Malware Analytics, where it will be detonated into a sandbox, and we can do retroactive blocking of it. Just turn on with the checkbox. Intrusion detection with your rule set, checkbox, and then the umbrella integration for DNS. Slightly more in a checkbox, you can paste an API key, but it's very, very easy to enable the security capabilities. And we do the XDR integration as well. That literally takes, it's like 10 clicks to get the integration going. So the Cisco XDR platform, you know, think of it as XDR, extended detection and response. So the whole idea with XDR is that it's meant to detect threats that the contributing products could not have detected alone. That's the definition of extended detection and response. So my firewall didn't see anything bad, my endpoint security didn't see anything bad. Maybe they both saw something unusual, but then the correlation of that data up in the XDR platform then makes a net new detection. That's XDR. And the integration we have between Meraki and Cisco XDR, super, super easy, and allows customers to get XDR outcomes very easily as well. So that was the Meraki use case here. So as you can see, rapid deployment and scale. From the one-touch provisioning, you can do templates in the Meraki cloud, but you don't have to, unlike Catalyst. The auto VPN makes just a breeze. Like, we have customers, I kid you not, that deploy 1,000 sites in a week with Meraki dashboard. It is that easy, because you order the sites, you can copy paste from an Excel CSV file of the serial numbers, those claim codes or the activation codes, and they'll all be onboarded, and you can attach them to a template, and they're passing traffic literally in minutes. The security features here, while we do not provide all of the fine tuning and so on, and again, not optimal for TLS decryption, but other than that, we get the same Snort engine and AMP and cloud sandboxing capabilities and so on that we have in firewall. So it's just a great all-around platform for secure SD-WAN. And last and not least, firewall threat defense. How many of you came here for this? I'm just curious. So a few people, because most of the folks in the room are running Catalyst, so it's interesting. So when we acquired SourceFire 13 years ago now, our ASA platform did not obviously have a SD-WAN capability set. It could, of course, build VPN tunnels, and it was the #1 platform on planet Earth for VPN tunnels. We still have just hundreds of thousands of deployments of them. When we built the firewall threat defense platform, we had simplified management in the cloud. We had, kind of these bandwidth controls and direct internet access. And yes, we could optimize connections for dual ISPs. But what we were lacking was a real WAN fabric capability in SD-WAN. This is going to be your DVTI conversation, by the way. So I was one of the primary architects of this, and we wanted to make sure that if customers wanted their primary outcome was best-in-class security capabilities at the branch, and yes, I need SD-WAN feature set, I didn't want to have to tell them to buy 2 boxes from Cisco and connect one into the back of the other. That doesn't go over very well, right? It's expensive, and you got to manage 2 things, and nobody wants that. So we built an SD-WAN feature set in the platform, and you don't have to dive into these abbreviations here real quick, but we'll talk about how that works in a minute. Now, for management of the secure firewall threat defense, we have a couple different options. There's an on-box manager called Firewall Device Manager. This is meant for standalone deployments, which obviously would preclude you from probably needing an SD-WAN feature set, so we're not going to talk about that. But what most customers use is something called Firewall Management Center, and we have both on-prem and cloud-delivered Firewall Management Center, and the cloud-delivered Firewall Management Center lives in this thing that I've mentioned a couple times now called Security Cloud Control. By the way, probably 90% of our customers are on-premises FMC. As we sell new firewalls to a new customer, it's about 70% of them go cloud, so I thought that was interesting. We do have a security cloud control tenant in Australia, and one in Japan, and then Europe, US, and Canada. So for customers that want to go this cloud option in Australia, it is an in-country deployment, in case any of you were wondering. Now, we do have zero-touch provisioning in the Firewall Management Center as well. So without walking through the steps there, you can see that. It's pretty similar. It goes by serial number. So in this case, it's slightly more work than on the router. As long as you have the serial number of the device, you can log into the security cloud control and kind of expect that serial number. When the device phones home to the cloud, it'll attach itself to your tenant. Now, the cool thing, and I suspect this might be your question, even if you're running an on-prem Firewall Management Center, we can broker that zero-touch provisioning. We broker it through our cloud, because your on-prem Firewall Management Center might not be directly connected to the internet. It probably isn't, right? Was that your question?
So my question is on the FMC on the cloud, is that deployment IRAP certified?
Is it?
IRAP certified? That deployment that's in Australia?
Yeah, so I believe so. Our data centers are SOC 2 certified, and we have FedRAMP certification in the US. And I could have swore we got that certification in our Australia data center, because I think it was a 1-to-1 with FedRAMP, except with Australian nationals running the data center. So, yeah.
And how many data centers do we have? 2 for redundancy? Or?
So how many data centers do we have? And I suspect you want to know about in Australia. Yeah. So our data centers run in AWS infrastructure. So even though it's one data center, like on a diagram. It is a highly distributed model across multiple, we use 2 different availability zones in Australia. So, they would both have to become a smoking hole, so to speak. And we do synchronize data unless the customer opens a ticket and asks us not to. So if all of the the security cloud control infra in Australia became unavailable because of some horrible AWS outage, we'd start advertising your IPs out the Tokyo data center, and hopefully you wouldn't know the difference. Hopefully, yeah. This is how we claim 100% uptime, right? Because we just automatically connect you to another data. This is why Umbrella never goes down. Umbrella goes down, but we have 44 data centers and we just automatically move traffic around. So we've never had an Umbrella outage. As a result, we do the same thing with security cloud control. All right, so now we're going to get into the tunnel stuff. So when we talked about Catalyst, we had that underlay overlay thing. Remember the OMP protocol and all that stuff? And you don't have to know how it works with Catalyst. It will just kind of configure itself. With Meraki, it was really easy. We had auto VPN, right? Super easy. On the ASA and FTD, it's a slightly more complicated, but still pretty simple. So we use IPsec, standards-based IPsec, to build our tunnels. And I'm sorry, that's black text on a blue little tube there, the blue hot dog. But we use this concept called a virtual tunnel interface. Now, a virtual tunnel interface creates a kind of a routed interface that once you configure it, it just looks like an Ethernet interface to the firewall. So if any of you have configured, just some old guys in here like me, if you've configured crypto maps before, those are horrible, right? Remember, it's like 5 minutes to configure the tunnel and like 4 hours to troubleshoot why it's not working, right? So with VTI, virtual tunnel interfaces, it's super dead simple. Like you configure, what's my peer address? Do I have, what's my password pre-shared key, or you can use a certificate. And then they just talk and the tunnel comes up. And assuming they have supported crypto ciphers on both ends and so on. So this concept of VTI becomes extremely simple. Now, VTI, the tunnel's always up, so you don't have to make interesting traffic. But by default, it's something called a static virtual tunnel interface. So in the example I just gave, a VPN tunnel from my firewall to you. You configure my IP address as the endpoint. I configure yours. Tunnel comes up. We're passing traffic, right? And we can write firewall rules against that interface. Now, by the way, this is what the CLI looks like. You don't ever have to see that. This works great if you're just doing a tunnel from one side to the other. If you got 3 sites, each site needs 2 tunnels. Okay, not so bad. What if you got 500 sites? Now it's not so good, right? So we implemented this capability, and this has been in iOS for almost 20 years, called dynamic VTI. So the whole point of dynamic VTI is, think I have 100 sites, and they're all connecting to a hub. If I used those static tunnels, on my hub, I would have to configure how many tunnels on the hub? 100, right? 100 sucks. That's time consuming. With DVTI, I only configure 1. I configure what's called a template, a virtual template. So DVTI, Dynamic Virtual Tunnel Interface, what you end up doing, and the GUI handles this for you and explain how it works under the hood here. The DVTI creates a template, and as tunnel connections come in, it kind of creates an ephemeral interface and attaches it to each tunnel. So this means your configuration on your hub is dramatically simplified. So this is what we do in FTD, and it gives us a very scalable kind of deployment here. And it is route-based because, again, all of these just look like regular Ethernet interfaces. I can ping across them. I can have a routing protocol peer, et cetera. And the nice thing here, as I add more spokes, I don't have to change configuration on the hub, right? Because and I don't, like with the old crypto map thing, you know, how many times did that happen? Like, I got 15 tunnels, and now I had tunnel 16, and oh, these other 3 went down now. What did I do? Like, you did some horrible overlapping configuration. Like, that problem's gone. So For the hub and spoke design, it is extremely easy. So you launch a VPN topology here. You pick route-based, you pick hub and spoke, and then you add hubs. I only got one here, but you can have as many hubs as you want. You add your spokes, you click go. You got to create a password in your appreciated key, and then just deploy it. And I do a demo and a longer talk on this, deploying a hub and spoke VPN to 6 firewalls. You click deploy, and traffic's passing in like 3 minutes. It's really, really simple. So yeah, depending on how fancy you get with your routing protocol, it can take a little longer, but it is very, very easy. We support, by the way, up to 1,000 tunnels, 1,000 spokes in a single topology. Now, if you have dual WAN interfaces, we can accommodate that as well, and we also support something called equal cost multipath, or ECMP, so you can have traffic go out both tunnels at the same time, et cetera. You can have a dual hub topology. You can get pretty fancy here. So I do a dedicated talk on this. We didn't run it in Australia here, but I did it in San Diego. If any of you want to dive into that deeper, you can go download that for free, the video and the PowerPoint as well. So very capable technology. Now, this is not auto VPN. There is a flow for this. I'll just show you what that looks like. So in 7.6, we created this topology, kind of call it a wizard. So you say, okay, I can either do a route-based VPN, and that's me manually adding the spokes like I just showed, or we can use this new topology wizard. By the way, policy one, don't do this. That's crypto map. So it was tell me like crypto map bad. No. Sometimes you still have to configure crypto maps on the firewall because that's not your choice. We do still support that. And when we get to this later, to the SASE, that's to connect up to our secure access. So why did we create the new wizard? When you use the new wizard, we actually handle the BGP routing as well. So it's not quite as easy as the Meraki MX, but it's pretty easy, as long as you're happy with the default choices we make. If you don't want the default BGP choices we make here, you can just manually create the hub and spoke, and it's still not that hard. So with the wizard, we do use iBGP. So iBGP, for those that aren't routing nerds, that means all of your branches have the same BGP AS, autonomous system number. If you use the manual route-based VPN and you configure 2 hubs and a bunch of spokes, that you're required to use eBGP, and all the spokes have a unique AS. That's a little bit of a difference there. So again, if you want to learn more on that, you can hit my talk there. So here's what that topology wizard looks like. It's super simple. In this case, I added 2 hubs. I added 4 spokes. I picked a pre-shared key, and I picked what I want that autonomous system number to be. Then scrolling down more, but I can't scroll. I said, okay, well, what is the security zone I want the tunnel to be? Because remember, in firewall, all of our interfaces need to be in the zone to create rules. Do I want BGP on? Yes. What's the AS number? I can create a community tag. This is optional. This is, if you're sharing the routes somewhere else, you want the tag on there so you can see where they're coming from. And we also support BGP multipath here with a tick box. And that's it. You hit go, and it deploys it, and you're routing traffic in 6 minutes or less. It's really, really easy. I'll save the demo. I'll put it in the WebEx space for you. It's just you watching me click around here for 2 minutes and passing traffic when I'm done. Yeah, I'll let it go. I'll answer your question. Yeah, please.
Yeah, I just wanted to check. When you say SD WAN capability activated,
yeah,
is it different from the Viptela solution?
So the question is, when I showed the workflow and I said, okay, I've deployed my SD WAN, is that different from the Viptela solution? Yes, it is. So this is using the IKE standards-based IKE v2 IPsec with our the dynamic VTI interface on the hub or hubs, static VTI in the spokes, and it is all standards-based IPsec. That is fundamentally incompatible with, so you can't take an FTD and add it directly to a Catalyst SD-WAN fabric. That uses that OMP protocol. It's totally different, right? This uses a standards-based IPsec, and it's at the end of my flow, and I click finish, and I would have you see the tunnels up here. So pretty simple. You can build VPN tunnels, WAN tunnels between firewall and Catalyst if you want to. It would just be separate from the standard SD-WAN deployment inside of Catalyst. We also support policy-based routing. And again, we tried to make this really easy. We added this feature a couple of years ago where we do path monitoring. So whenever you configure an interface on our firewall, there is a path monitoring kind of tab. You tick a box, turn it on, and what do you want to monitor? And you get some choices. I want to monitor the next hop, or I want to monitor some IP address on the internet. I always monitor some IP address on the internet because my next hop's my internet provider's box that's sitting next to the firewall, and that thing never goes down. It's always something further away, right? So you have your choice there. And with that monitoring on, now you can instantly make policy changes. So we support both ICMP path monitoring and HTTP path monitoring. We'll actually make synthetic TCP connections, like in this case to WebEx. So I could say, well, what's the real, this if I got two internet links, I want to use the link that has like the best actual performance to some web apps or something. We support that here. And we also support the ability to do policy-based routing based on identity. And this is pretty slick too. So we had this feature on Catalyst, if you recall. It said, hey, you can do routing based upon TrustSec tag. We added that feature to firewall as well. What I really love about this, the common example here is when you have things like guests or IoT devices. And I don't know who the guest is, and I don't know what the IoT device is, but if I can assign them a TrustSec tag, I might do something like, hey, for my IoT devices, I don't ever want them going direct internet access. Maybe I want to send all that traffic over my tunnel to my headquarters, because that stuff shouldn't talk to the internet very much, and I don't know what it is, as an example. Or you can say, well, it's an employee on a personal device. I might send their traffic out a different path. You get the idea. So those TrustSec tags and routing allow you to do some pretty fancy things here. Now, in firewall, we do a bunch of cool monitoring as well, site-to-site monitoring and tunnel monitoring and all the stuff you'd expect. A couple of screenshots to show you what that looks like here. So here's the overview. It's my real deployment here, so I blocked out some IP addresses. So, status of my tunnels here. If there's any errors, you'll see those. And on the next screen here, I drill down into a tunnel. And now this is like real small in the room here, but if any of you have done the CLI on a router or firewall, like the show, crypto, IPsec, SA, and all that stuff, that's all this. So I didn't want the customer to ever have to go into the CLI and the firewall. It's like pain in the ass, right? So for all of that kind of troubleshooting, you can do it right from the firewall management center. So you can drill down in a tunnel, and we do the show, crypto, IPsec, SA. We pull up all the stats, and you can see exactly what's going on, just like you were on the command line. You can still go into the command line if you want to, but I didn't want you to have to. That's a question?
The SD-based routing in Catalyst SD WAN, is it version specific? When was it introduced? In what version?
When was the
SD-based,
for Catalyst. Boy, it's been in there a couple years, but I don't know what version it was implemented. If you shoot me a web message in the WebEx space, I'll ask the product manager tonight. So, shoot me a message in the WebEx space, I'll find it for you. All right. Now, for branch security and firewall, I think it's well known the broad set of capabilities here. NGFW, intrusion prevention, integrated TLS visibility and decryption. This is our number one platform for encrypted traffic inspection, and in my opinion, this is the number one platform, even when you include all of our competitors, on encrypted traffic inspection. Not only in our ability to decrypt, we can decrypt quick and all versions of TLS. We also have a bunch of advanced patented features like TLS fingerprinting. We have encrypted visibility engine. These are capabilities that allow us to inspect traffic and make judgments on traffic, oftentimes without having to decrypt, which is pretty nice. And this gives us this kind of we used to say Russian doll model, but it doesn't resonate very well anymore. But this model where you have, okay, I have all my security intelligence feeds that I can apply to traffic, and if there's bad stuff, I drop it. Well, if that doesn't do it, I can do integrated Umbrella DNS inspection. Hey, does Umbrella have a kind of information about this thing, and maybe drop it? And then I have encrypted visibility engine look at it. Does this fingerprint it as malicious? No, and you get the idea. And as you kind of get down and down, one of the last steps is you get into, okay, well now this is something unusual. I want to decrypt it, and I can run my IPS inspection in AMP. So this is kind of the model with firewall for Cisco Firewall for inspecting traffic. And when you decrypt, this is expensive. It's computationally expensive, and it has it raises the likelihood of a possible interaction with the end user if an application doesn't take kindly to decryption. So this is the way we built it this way. In the latest version, 10.0, which launches in 2 weeks, we basically have a one-button method that it automatically instantiates this kind of automatic security and decryption policy that only takes effect after all of these other inspection methods are done. This is way different than Pan, Checkpoint, and Fortinet do their decryption. You configure their decryption rules, and they decrypt all that stuff, no matter if it was known good, known bad, whatever. It's just a much better method here. You'll get the deck. Well, here, I'll go back so you can take it. I spent hours making this damn slide, so you can take the picture there. So from a firewall threat defense standpoint, the optimal use case here, that third bullet, best-in-class edge security capabilities, especially for encrypted traffic. So when we have customers that are like, thank you, we have customers that are like, hey, my SecOps team wants to, maybe we're replacing Catalyst and we're looking at Pan Firewall or Fortinet or whatever, like, hey, you're going to look at FTD here because I want to put our best-in-class security platform against what they're looking at. Or if customers that they were using an ASA, and now they're like, hey, I need SD WAN features, I need application visibility, NGFW, great use case here. So also the customizable VPN and routing capabilities, we have wizards in there to make it really easy. I showed you those. If you want to manually tweak things and have very sophisticated specific policies and crypto ciphers and all that stuff, this is the best platform for it. This is also where both in Catalyst and FTD, but in FTD first and foremost, this is where we're prioritizing all of our post-quantum safe crypto algorithms. Will show up here first. We are running them in a lab right now with some draft standards. So. In 2026, look for a post-quantum safe crypto release. It's actually in the ASA code already, kind of unannounced. But if you go into the GUI for ASA, something called ASDM, you'll see the post-quantum tick box in there. And we're doing testing with key exchange companies now. So last topic for you. And we're right on time here. The clock shows 13 minutes. I should have a couple more minutes for questions at the end. We've kind of compared and contrasted the three platforms. And the last quick section here, we'll talk about how we integrate all three of these offerings with our security service edge known as Secure Access. Now, I'll start up front. Everything I talk about here will also work for connecting these three platforms to a competitor's security service edge, whether it be Prisma Access or Zscaler or Netscope, or I don't think anybody runs the Fortinet one if they're not running Fortinet. It should in theory connect to that. This will work for all three. Now, what is Secure Access? Well, Secure Access is a cloud-based service that provides security inspection and so-called zero trust, least privilege access, right? So on the left, you have your clients. They could be standalone clients, laptops, managed, unmanaged, or you could have, where I got the little IPsec tube, you can have a branch, and that branch could be running Catalyst, Meraki, or FTD, or competitor's product. And the Secure Access also needs to talk to private apps on the back end, and that's where you could have firewalls here or secure routers and connectivity. Now, when you have traffic coming from one of the branches or from a remote user, it kind of goes through this traffic acquisition where you have a proxy, you can take in network tunnels, browser-based connections, and we have remote access as a service. All of the Secure Access security functions run in the cloud, And then if the user's accessing an internet or SaaS app, out to the internet. If the user's accessing a private app, it goes obviously to the cloud or on-prem data center. Now, that was a 60-second overview of what a security service edge is. Why would I connect my secure branch to a security service edge? There's always a question I get. Like, I got a firewall right at the branch. Like, why would I send it to the cloud firewall? Like, shouldn't I just do all that stuff on the edge firewall? Well, there's a bunch of stuff that edge firewalls can't do as well, or can't do at all, depending on your point of view. So for internet security functions, well, umbrella DNS. So us and every competitor has built-in DNS security. I think PANS has caches like something 20, 30,000 known malicious DNS entries in their firewall. And if you turn on their DNS security, it will match all lookups against that cached list of 20 or 30,000 entries. Umbrella DNS, billions of entries, billions. Umbrella DNS also keeps track for every domain on planet Earth when the domain was registered. And now it can automatically do things like, hey, I have a user trying to connect to a 400-character FQDN for a domain that was brought online this morning. What are the odds that's good? Like 0, right? So these kind of, we call that dynamic name generation domains. Umbrella has quite powerful capabilities here, and our security service edge, known as Secure Access, has this built in. DLP and CASB controls. Now, can you do DLP and CASB directly on a firewall? Yes. But the extent that which you can perform DLP functions are very difficult to manage and for a firewall to cache, especially at scale. And CASB controls, my least favorite acronym, Cloud Access Security Broker. What's CASB? Let's say I want to let my users download stuff from Dropbox, but I don't want them uploading to Dropbox because we're a OneDrive shop. They shouldn't be uploading to Dropbox. You need a CASB control to do that. It's an application control. And while, yes, you could, in theory, do CASB controls on a firewall, and some of our competitors do, we support thousands of applications in CASB in the cloud, and we can update them in real time because SaaS apps change and update in real time, and this doesn't lend itself well to a firewall function that would need a feed to do this. Cloud protection and sandboxing, decryption. Decryption's a big one, especially kind of post-COVID. We're doing this hybrid back to the office thing. Well, 3 days a week, I got 20 people in the office, and 2 days a week, I got 400. All right, well, I guess you got to buy the firewall that scales to 400 for your decryption policy now. Well, that kind of sucks, right? Because those people go home, and I still need to scale the cloud for the 400 times all my offices. So with this model, you can have potentially a more modest firewall or router, MX, FTD, Catalyst, at the branch. And now you can do all of your decrypt in the cloud. Now, if the user's at home or they're in the office, Cisco's cloud has scaled based upon the number of employees you have, and you don't need to overbuild your capabilities for your platforms all over the place. So on the private application side, also this gives you quite helpful capabilities here, because today most of our users are kind of everywhere. They could be at home, they could be at the office, they could be traveling, like half of us here in this room. Likewise, the applications could be everywhere. So where's the perimeter? Where should we have the security hosted? By using a security service edge and centralizing policy in the cloud, no matter where the user is, no matter where the app is, you can have that centralized connectivity. And even if that means a branch firewall, in order to get to the app, has to go through the security service edge, you've centralized that, you've centralized policy. So for integrating, and we'll talk about how the three platforms integrate here, we do this very easily. So I start with firewall because we just ended with how the firewall SD WAN works. I walk through the hub and spoke topology, exact same thing for secure access connectivity. Except now we have a button that says SASE, that one I showed you on the right, but it builds a hub and spoke topology. It adds your two secure access hubs. With secure access, by the way, unlike our competitors, all branches we configure what's called a tunnel group. So we always build redundant tunnels to 2 data centers. And we automatically fail over from one to the other. And then even if a data center fails, we BGP anycast its IPs out another data center, so you're always up. So the integration with firewall and secure access is really, really easy with this hub-spoke model. And we support either eBGP or static routing to those. If you're just using secure access for kind of internet security, most customers just use static routing. But if you're using it for private applications, now you probably want BGP because secure access will automatically advertise down just the networks that that branch needs to know about to get to the private apps it's protecting, right? The configuration for this, kind of leave this in for reference. It's pretty simple, and kind of walking through. The only note I would give here, I'm a big fan of using route maps because you're connecting to a cloud thing with BGP. And if one of your coworkers foobars something at another site and starts advertising a million subnets up, it might not be what you want. So, use route maps for that. In secure access now, we just introduced a new route troubleshooting tool a couple of weeks ago. Speaking of FTD, this is just an example, so I thought it was interesting, so that means I assumed you guys would do. This is what the routing table on a firewall would look like if you had a couple tunnels to secure access, one internet link, and an SD WAN connection as well. So I did show route. We see our default BGP route learned via secure access through the tunnel. See the B's for BGP. I got static routes to my hub and spokes out my internet link, and then those V routes, when we use the VTI routing, when one of our spokes connects to a hub, and remember I said the hub just automatically accepts spoke connections? Well, how does the hub know what the IP address is on the end of a spoke if it doesn't have a unique configuration for each spoke? Good question, right? So how it knows is we use a feature in IPsec where our spoke advertises its tunnel address across to the hub, and it shows up as a V route. And the spokes, they learn the hub address as well. This allows things like a routing protocol to peer. We also offer something called hybrid private access. And hybrid private access allows us to, if you're using an FTD firewall, you can tell secure access about it, and instead of your secure access users always going to the cloud and building tunnels to the cloud, they'll build a tunnel to an on-prem Cisco firewall, and that can often be a highly optimized experience for the end user. Pretty slick capability. The tunnel automation here, I'll skip the demo. You just click SASE topology, and it does the automation for you. Now, on the Catalyst side, likewise, we have some special sauce here. Sorry about that. On the Catalyst side, we configure a template. Remember, so everything Catalyst is templates. So now we have a cool capability in Catalyst where not only do we build the tunnels to the primary and secondary secure access hubs, on Catalyst, we actually support bundling multiple tunnels together. We call this equal cost multipath, or ECMP. This is an old slide. We actually support 10 tunnels now. So if you have a branch site that's like at 10 gigs of bandwidth, well, we only support 1 gig per tunnel on the secure access side. The Catalyst will automatically build 10 tunnels, both to the primary and secondary secure access hubs, and it'll bundle them together, and now you can have 10 gigs of bandwidth each tunnel. Yes, sir?
Why do you have 1 gig limit on that tunnel?
Why is there a 1 gig limit on the secure access side? The reason why we do that is because even though the infrastructure is unique to per customer, we call it a shard, in the data center node, we have a fixed amount of, I think it's 40 gigs per shard, a fixed amount of bandwidth coming in, and we need a predictable way to know what the max bandwidth a given customer will be using. The overwhelming percentage of customer branches of all of our customers are never more than 1 gig per tunnel. So we artificially set the limit at 1 gig. With Zscaler, it's 250 megabits, by the way. So we do have the ability to raise that tunnel limit, but you have to open a ticket with TAC, and now we keep track of who those customers are so we don't overload that data center, if that makes sense.
It's not a technology limit, it's some limit you have.
It's a limit we have applied, yeah. So secure access with SD WAN. We also have the ability to use those VPN ID and SGTs up in the cloud here. And we can actually use the SGTs and VPN ID in rules inside of secure access, which is pretty slick. And that gives us the ability to do segmentation based upon those SGT or VPN ID up in the cloud. Remember the VPN ID, that's the police department versus the fire department. That would be that kind of VPN ID. And then the tags would be those colored tags I assign to users or devices, et cetera. I'll put this demo in the room here for the sake of time. This just shows how that integration with TrustSec works inside of the Catalyst SD-WAN. We'll end on the Meraki here. Now in the Meraki, we had a solution called Cisco Secure Connect, which is still live for a bunch of customers. This was a kind of a specially crafted version of secure access just for Meraki. And we're actually migrating all those customers just to standard secure access now. The special thing that we've done here is we've integrated auto VPN. So remember I said Meraki's got that cool auto VPN. So if it's a Meraki customer, we actually spin up virtual Meraki MXs in our cloud and directly connect them to secure access. It's a pretty nice experience. So and this uses that same BGP over IPsec I talked about earlier. We did this in part for secure access. So wrapping up here, this is my summary here, and I can have we're right at the time. Our scalable solutions here, all of the platforms support up to 1,000 sites. They all support app-based routing. They all have robust on-site security capabilities here. So hopefully we've given you guys a good flavor of some use cases where one platform is ideal, perhaps more than another. But again, there's no bad choices here for the customer. So guys, that's it for me. I'll stay up in the room to answer any QA, but I want to let folks leave on time. So thank you very much.